Yeah, it's nice to connect with you all. Excited to share what I've been working on. I think it's maybe not the most typical crowdsourcing application, but it's in the particular context that I think has interesting considerations for bias, and we've been thinking a lot about how to kind of manage that. So first, I'll talk about our application. It has to do with labeling medical data. So it requires some advanced training to do that, meaning that our annotators have varied skills and experiences and expertise. So I'll share a little bit more about that. And then how we went about measuring the accuracy of our resulting annotations, given the context. And then also how our annotators relate to the tasks that they're given, because it turns out to be a learning opportunity for them as well, which kind of shapes the incentives, but also concerns related to how they're working with our system, and also what biases might come up. So, and how we understand the potential for that. So, first, the platform that I work on is for annotation of electroencephalography, or EEG. It's a brain voltage, basically. It's a signal data, and it's used for neurodiagnostic research. So currently labeling this type of data is reserved for the most board certified neurologists. So there are plenty of other EEG professionals and even professionals in training programs who have the skills to identify the events and patterns in this data, but they won't be as accurate as the neurologists. Even the best neurologists are only estimated to be 80 or 90% accurate. And right now that's the gold standard. So if we were going to use this data for training any kind of automated algorithms, we'd have a really hard time. Not just for the algorithms to give us, good results, but also to understand when it's accurate and when it's not. So that's something we've been working on a lot. And then our, motivation for leveraging a crowdsourcing approach is that in agreement, these EEG professionals and technicians, even though as individuals they're not as reliably accurate as the neurologists, if they agree, then they're actually probably able to generate more reliable annotations overall. So just to give you some ideas and examples of what this context looks like, the EEG is collected in a clinical setting. A lot of times it has to do with patients with epilepsy, but other neurological conditions as well. And then the EEG recording, along with some corresponding clinical information, would be uploaded to our crowdsourcing platform. And then the annotation task is kind of interesting because it could be a binary question, like this is a seizure or not. This is a particular kind of spike in the signal or not. But it could also be multidimensional, where parts of the annotation might be correct, while other parts there might be a mistake. So where we're at in the development of this is focusing on the most simple tasks first, and also recruiting the technicians to participate. Once we have annotated EEG data, it could be used for finding biomarkers like connections between certain kind of events and patterns in the data with neurological conditions. It could also be used to develop kind of automated algorithms so that the technicians in clinical settings are the more simple tasks can be automated so that they can spend their time analyzing other situations in the data. So there's a lot of nuance potentially, which also contributes to the potential for bias. So depending on the annotator's specialty and experience, they might be more inclined to recognize certain patterns over others. So for example, one event in someone who has a trauma issue might look different than the same thing to be annotated in a pediatric patient or someone who's sleeping. So these different states kind of impact what will end up getting labeled. And depending on, if someone has a lot of experience with trauma, for example, then they'll probably be more likely to come up with accurate annotations in that domain, whereas they might be more likely to misidentify types of tasks where they have less experience. So that is interesting for us to consider. And then there's also the issue of how the annotation tasks are presented. So this could be like priming them. So as I mentioned, there's different types of annotations that could be applied to the same segment of EEG data. So if we are presenting the task, is this a seizure or not, then we're kind of primed to look for seizure activity. Alternatively, if someone has a lot of experience with a certain kind of condition and they see something that looks like that is going on, you might be able to tell I'm not a neurologist, but I do work with the data. So anyway, how we present the annotation tasks could influence like how they're interpreted. I also mentioned this is a potential training tool. So the EEG technologists who are in training especially would be able to contribute their annotation guess or their vote, and then receive feedback on how the rest of the crowd has interpreted that EEG segment, which could be helpful feedback for learning. But I think it's also an interesting opportunity for us, at least while we're still in development, to solicit from the annotators what are the sources of misunderstanding, and then using that to iterate and adapt our platform. Cool. So when there isn't a kind of ground truth, because even our expert annotations might have some inaccuracies in them, we can use iterator reliability to get an estimate of how accurate each individual is based on how often they agree with the crowd. So I'm sure many of you are familiar with that idea. But once we have an estimate for individual accuracy, we can also estimate the accuracy of the annotation that is generated based on Condorcet's jury theorem. So that was originally, I think it's just a probabilistic approach to how likely a group comes up with a correct answer based on the accuracy rate of each individual. And we have this proxy of inter-rater reliability to use as an estimate of individual accuracy. And then our accuracy of the annotations improves with crowd size as long as each individual participant's accuracy is greater than 50%. And that's turns out to be doable to achieve even for technicians in training. So what that gives us or lends itself to is this kind of cycle of improving accuracy for the annotations. So even though we're not able to kind of pre-populate the system with gold questions or like gold standard annotations to compare with, we're able to kind of get those retroactively by estimating the accuracy rate of the individual annotators, using that to come up with a confidence metric for the resulting annotation. And then if our confidence is not very high, we can have more and more participants trying to review and interpret that annotation task. And then once we have a better sense of our confidence metric, or what is the most likely probable annotation to be correct, then we can use that instead of inter-rater agreement to have a more specific estimate of individual accuracy rates. And if that is the case, then we can also improve our confidence or that calculation of how likely our annotation is correct becomes more accurate also. And this is particularly interesting because I mentioned our EEG professionals and technicians, they might have different areas of expertise. So one thing we may be able to do is to kind of scaffold these tasks, or the calculations at least, by information that we know about the annotators. So 50% accuracy rate could break down into like a very high accuracy rate for the case of identifying seizures, but a very low, like less than 50% accuracy rate for a type of task where the individual has less experience and they might not know ahead of time which tasks they're good at or not. So they get that feedback, but then also we're able to maybe only apply their annotation contributions when they're working with one of their areas of more knowledge, basically. And then, this is interesting for us too, because one thing to consider is if our annotators are using our crowdsourcing platform as also a training tool, then potentially their accuracy would be improving over time. So if we're estimating their accuracy rate based on when they very first started their training, then we might not be fully leveraging the skills that they're developing as they continue to work on this. Cool. So given this context, I think we have some interesting things that we've been considering about the crowd workers, the people who are annotating the data. We actually interviewed a few neurotechnologists and asked if they would be interested in participating in tasks like these, and like what they might benefit from doing that. So training or getting better. A lot of times the technologists have a requirement to satisfy continuing education credits just to stay up to date on the field and things like that. So continuously learning and improving their skills is beneficial for them and makes sense. It could also be a job requirement. So it's possible that residents in neurology medical centers could be contributing to, for example, if it's a research hospital, the research hospital might be very interested in having their data labeled for research purposes that I kind of mentioned. And they might be able to leverage the neurology residents to kind of bootstrap that data labeling. So just as an example, there's one children's hospital that I work with who we know of, just as this one site has hundreds of terabytes of data that is not currently labeled, so it's not utilized in the kind of research that it could be. And also the neurologists who are currently able to read and interpret those just would never have the time, or even if they did, that would be very expensive to get all that data labeled. So kind of approaching it this way could be a way to accomplish multiple goals at the same time. Some of the people we interviewed were also just kind of interested in the data itself and like contributing to these kind of automated algorithms and just pushing the research forward. A lot of them are genuinely interested in pushing the field forward from their roles, and there's a little bit of a concern like, oh, are we contributing to the AI that's going to automate or take over our jobs? And that's not the case, actually, because mostly we would just be, especially at first, more focused on the research applications and like finding biomarkers. But even with developing the automated kind of labeling algorithms, we'd be able to, like I mentioned, automate simpler tasks so that they could spend their work time on more interesting problems. There's another aspect of our kind of arrangement, and that we need to know certain things about the annotators because they have to be qualified to participate. So they have to have some kind of relation to the field and knowledge. So we need to keep track of who they are, which could have some interesting implications related to, if we are also calculating and keep, estimating how accurate someone is at labeling, then that might be sensitive information for us to navigate or, handle interestingly, but also kind of relates to potential incentives for honest engagement with the system. And then the last thing is that disagreement among the annotation tasks could be indicative of how complex the task is. So there are neurologists who are participating in annotating the data, but this platform, this setup would give us a way to direct the most complicated or nuanced tasks to the most highly accurate participants in our crowd. It's kind of cool. So just some kind of like high level things that we're interested in, or having conversations around, are the nature of the annotation task. Being complex means that there's potentially error and bias even among experts. So that's why we need a reliable way to assess and improve accuracy. We use the estimated accuracy rate for our annotators to come up with accuracy rate for the annotations, and then in turn kind of continue to solicit annotations until we've reached a confidence metric that we're happy with. And there has been some other work related to having multiple reviewers per annotation task, because we know that even an expert isn't perfectly reliable, but right now the way that's approached is kind of like, oh well, 2 or 3 probably means it's good enough. But we've explored this way of kind of quantifying how what it is to be good enough, or like what the good gold standard really should look like. And then finally, just interesting to think about how the motivation to participate in crowdsourcing can be shaped by the relationship to the field and the data. So if there's a potential for learning or improvement on the annotator's part, then we're hoping that's a promising way to engage, but also gives us a lot of space to explore like patterns in the voting data, and then also learn from that. So this is all still pretty early work, but yeah, we're excited about something we think we'll be able to do.